There's no doubt from Corey's face that he loves skateboarding. Corey and his friends visit Newton's skate park every chance they get. They may not know it, but while they're having fun on their skateboards, they're actually applying science concepts such as forces and motion.
Have you ever ridden a skateboard? Even if you haven't, you probably know that to start a skateboard rolling over a level surface, you need to push off with one foot against the ground. That's what Corey's friend Nina is doing in this picture. Look how Nina's friend Laura does it. She steps back down on the back of the skateboard so it scrapes on the pavement. This creates friction, which stops the skateboard. Even if Laura didn't try to stop the skateboard, it would stop sooner or later. That's because there's also friction between the wheels and the pavement. Friction is a force that counters all kinds of motion. It occurs whenever two surfaces come into contact.
If you understand how a skateboard starts and stops, then you already know something about Newton's first law of motion. This law was developed by English scientist Isaac Newton around 1700. Newton was the greatest scientist of all time. He developed 3 laws of motion and the law of gravity, among many other contributions.
Newton's first law of motion states that an object at rest will remain at rest, and an object in motion will stay in motion unless it is acted on by an unbalanced force. Without an unbalanced force, a moving object will not only keep moving, but its speed and direction will also remain the same. Newton's first law of motion is often called the law of inertia, because inertia is the tendency of an object to resist a change in its motion. If an object is already at rest, inertia will keep at rest. If an object is already in motion, inertia will keep it moving. That's all fine and good, but let's see if Miss Tay can help us out with a real-world example. Miss Tay, how did you use Newton's first law to start that chair rolling?
The chair will not move unless I push off from the carpet with one foot. The force I applied when I pushed off is stronger than the force of friction that opposes the chair's motion. As a result, the force of the chair is unbalanced and the chair moves forward.
From watching this video, you should have a better understanding of Newton's first law, friction, and inertia. You also should have some concept now of force, as we talk about it in a scientific way.